Welcome to another exercise in a workbook statistics. This time I'm going to present an exercise on the hypergeometric distribution. Let's have a look at the exercise. A university offers 3 study programs: National Management, Regional Brand Management, and Physiology and Management. The study programs are frequented by 51, 32, and 17% of all students respectively. So much for the general information. And we also know of all 400 students at a particular campus, each year 9 members of the student council are selected. Then our first question here: what is the probability that none of the students in a student council study PM? Second, what is the probability that at least 2 of the students in a student council study PM? And finally, what is the probability that the student council will consist of NM, so of national management students only? Well, before we can start with this, we first have to clear why are we actually going to use the hypergeometric distribution here. Well, if we select students for a student council, we're going to select 9 different students. We're not going to select 9 times the same student. We cannot select 9 times the same student for the student council. So once a student is selected, he cannot be selected again. That's what we call selection without replacement. And that's a definite indicator that we have to use the hypergeometric distribution. So, well, that part cleared. We can work for the next parts with the hypergeometric distribution. Starting with part A, the first exercise, we want to know that none of the students has the proper characteristic of studying PM. Well, what do we know? We know that of the 400 students we have, 68 study PM. That's by just using the shares we had on the 400. And we know that we draw a sample of size 9. So we have large K, large N, small k. So we have everything we need for our probability function. So we can simply use probability function for the hypergeometric distribution, which is just large K over small k, large N minus large K over small n minus small k, divided by large N over small n. So that's representing those in the whole population and in the sample that study PM. That's the opposite. That's those in the whole population and in the sample that do not study PM. That's just the overall number of students in the population and in the sample. Well, putting all of this into our calculator gives us a result of 18.35%. So the chance that we will not get any PM students in our student council is slightly above 18%. Well, that was already the first part. So let's continue with the second part. Here with part B, what we're actually looking for is the probability that at least 2 of the students have this characteristic we're looking for. Well, at least 2 would mean 2, 3, 4, 5, 6, 7, 8, 9, or 9. So that would be 8 probabilities we have to calculate. If, however, we use the counter probability, so 1 minus and then x being really smaller than 2, we only have 2 integers which are really smaller than 2 and still positive. That's 0 and 1. Well, positive for the 1 and 0. So instead of calculating 8 probabilities, here we only have to calculate 2. So that's much easier, in particular since this part we already did in part A. So for the other one, we have the same information as in part A. Large K 68, large N 400, small n 9. So we're just going to copy the result from part A, and here we're going to insert For small k, the 1, and the rest as is before. So large K, small k, large N minus large K, small n minus small k, over large N over small n. So we get as a total 46.99, or roughly 47% chance that at least 2 students in the student council will study PM. Well, that was already the second exercise, so let's turn to part C, the third and final one. Here in C, what we are looking for is that all of the students study national management. Well, that's actually pretty straightforward, because what we can do, we can simply take the probability that one of the students will study national management and take it to the power of 9. We know from the exercise text, probability that someone studies national management is 51%, so 0.51 to the power of 9 will give us as a result 0.0023. So the chance that there is a student council consisting only of members who study national management is just 0.23%. So less than 0.25%. And well, that was then the third and final part. So this concludes the exercise, which I hope you enjoyed. I say goodbye and see you next time.